In this video here, we're going to continue the review, starting with number 7. So it says here we need to solve for the system of linear inequalities by graphing and shading for the solution set. So first off, let's review a little bit. Whenever we're talking about graphing an equation, you need to be able to make sure that the y is by itself first, which in our case, the y is by itself in both of these sets of equations. Because when you have the y by itself, you can identify what is your slope. And so notice that I can easily figure out what my slope is here and what is my y-intercept. You need those two ingredients to be able to graph a line. And you also need to be able to identify what type of line to draw. So if you have inequalities like the ones with the line underneath, like these inequalities mean you need to draw a solid line. Whereas the inequalities without a line underneath, you need to draw a dashed line. So that might be nice tips to have when it comes to drawing your graph. So for the first one here, I am going to label my equation. So maybe I'll call this one equation 1, that's in pink, and equation 2, that is in green. So my first equation, I notice my slope is -3 over 1, and my y-intercept is at 5. So I'm going to go to the y-axis at 5 and use my slope. So -3 means down 3 here and over 1. If I go ahead and plot this, I need to connect the dots using a line, and in this case, this inequality does not have an equal sign or a line underneath, so I need a dashed line to connect the dots. So once I form my dashed line here, I'm going to shade depending on which region. So this here said y is smaller than this equation. If y is less than this equation, you need to have y's that are negative or smaller. So this is in the negative direction. So I need to shade below this line. If I were to shade above it, these are where y gets bigger and bigger. So I don't want to shade above, I want to shade below. So I'm going to grab my highlighter here and shade below this line. All right, now I'm going to get ready to graph my second line here. So my second line is going to be located in, let's see, we have a slope of 1 technically, because the number in front of this x is 1. So this is 1 over 1. And my y-intercept is at -2. So I'm going to go at -2, sorry, not -2, -1. My y-intercept's at -1, so I've plotted that. And my slope is 1 over 1. So I'm going to go up 1 over 1 and plot. And in this case, there is a line for this equal. So this line here for the inequality is going to allow us to draw a solid line for our graph. And for the shading part here, it says that y is greater than this equation. So here's our line. If y is greater, you want to shade above the line. So that tells me that it looks like my graph intersects right here. So that is my solution set or my intersection. So this is the part that I really care about for our graph. So I'm trying to figure out where do both colors meet, and they actually meet right here. And that's it. All right, let's take a look at part 8. So this one here gets a little interesting, but again, I am going to label my equations. The y is already by itself, so I can easily tell my line here has a slope of -1. So this one has a slope of -1. So -1 over 1. And I also have a y-intercept at 5. And then for my slope, I need to go down 1 and over 1 since it's a -1. And there's no line underneath this inequality, so I need a dashed line to connect the dots. From there, I need to graph my second line, which is y is less than 2. So because it's just a 2 here, this is a horizontal line. So because it's just y equals, we have a horizontal line. Anytime it's like x equals a number, that's when you have a vertical line. So just as a quick reminder. So if we have a horizontal line at y equals 2, I do need a solid line because there is a equal sign here for this inequality. So I'm going to draw a solid line. And I'm about to do my shading here. So for the first equation, let me see if I can get my highlighter here. So my first equation is this pink line, and it says that y is less than this equation. So if y is less than, you want to shade below the line to grab the y values that are negative. So this would be shading below that pink line. Now for the green line here, or the y is less than or equal to 2. So if y is less than or equal to 2, you also want to shade below the green line, because these are y values that are below 2. So in that case, it looks like the two colors intersect right here in this weird like trapezoid shape. But let me get a thicker highlighter. Right here is where they intersect. And there we go. So hopefully that gives a better example of how you can graph inequalities. Let's take a look at number 9 here. So for number 9, we're testing if this coordinate, so coordinates are x and y values, is a solution for the following system. So we've done quite a bit of these. If we want to know if something's a solution, we can just go ahead and plug it into the equation. So I have two equations here. All I need to do is plug x and y into the equation and see if I actually get the numbers that are to the left or to the right of it. So I'm going to take my first equation, 2x, which x is 3, minus my y, which is 1. And this needs to equal 5. Well, 2 times 3 is 6. If I bring down the 1 and subtract 6 from 1, that does give me 5. So both sides do equal 5. So that is good. I'm going to put a little check mark there. For our second equation, we have negative 3x plus 5y equals negative 4. So let's take a look and plug in our x. So we have negative 3 times 3 plus 5 times 1 equals negative 4. So I've plugged in my x and y, and I'm ready to work out the left side here. So this negative 3 times positive 3 is negative 9 plus 5. And negative 9 plus 5 does give me negative 4. So this does work out for both equations. If they work out for both equations, that means this is a solution. So we can say yes, it is a solution. All right, let's move into problem 10 here. So for number 10, we are trying to figure out or solve the system equation for the 3 variables. So this is a multiple choice question where you have to figure out which one of these 4 coordinates is the correct one that works out for all 3 equations. So here's the nice part. If I were to plug in my numbers and they don't work, then I can move on to the next coordinate point to test it out. So the hard part is that I have to test out one until they work. So it could be all of them until I figure out which one works. So I'm going to just start with A here. And remember, these are your x, y, and z values. So if I start with A and I take 1 and I plug it into the first equation. So I'm just going to plug it into the first equation as 1 plus my y, which is negative 2, plus my z, which is 3. I'm going to check if it equals 0. So 1 plus negative 2 is negative 1, plus 3 is not 0. It is going to equal 2. So this means that A is not the correct answer because it already failed here. This is not true. So I go on and move on to B here. But again, I have to start with the first equation again. So here I go. If I take the first equation, plug in my 1 for x, That would be 1 plus my y, which is 2, plus my z, which is negative 3. And I'm going to check if this equals 0. Well, when I look at these numbers, 1 plus 2 does give me 3. If I add negative 3 to positive 3, that does give me 0. So I can already see that this first equation works. So I have the first equation. Let's try the second equation. So we keep moving if it does work. So my second equation, I'm going to plug in my same coordinate. So I'm going to plug in 1, plug in 2 for y, and plug in negative 3 for z. So 2 times 1 plus 3 times 2 minus negative 3. And does it equal 11? So 2 times 1 is 2 plus 6, because 3 times 2 is 6, plus 3. So if I take 2 and add to 6, that gives me 8. Add a 3 to 8 is 11. So this part does work out. And I'm kind of like quickly checking. And for the third equation, I'm going to plug in, again, the same points, or the same x and y and z values. So if I plug in 1 in for x, I have negative 2 times 1 plus y, which is 2, minus 2x. And does this equal 6? Let's find out. So negative 2 times 1 is negative 2 plus 2 plus 6, because negative 2 times negative 3 is plus 6. And so if I take negative 2 and add it with 2, that's just, they cancel. They end up being 0. And so all I'm left with is 6, and 6 does equal 6. So this works out for all three equations. That means that B has to be the answer, and I can just stop right there because I found a point that has worked. All right, so moving on to problem 11 here, we're going to be solving a 3 by 3. In order to solve a 3 by 3, let's take a look at what we're given. So when we get our solution should look like it has a x value and a y value and a z value. If I really look close to this equation here, my 3 equation, I start to notice that my third equation, they already tell me what my z value is. So they tell me that my z value is negative 3. So that's kind of nice. Now I just need to find x and y. And I can easily do that by plugging in my z value into the second equation because there's only 2 variables to begin with. So if I plug in my z value, I can find y, which is what I'm going to do down here. So if I take y plus 2 times z, which is negative 3, and I work this out, I have 2 times negative 3, which is negative 6. If I add 6 to both sides, that cancel, and y equals 5 plus 6, which is 11. So my y here is 11. Now, if I want to figure out my x, I can go back to the first equation, plug in my y, plug in my z, and then all I'm left to solve for is my x. So we have x plus 2 times y, which is 11, minus z, which is negative 3. And let's see if we can get our x by itself. So we bring down x. 2 times 11 is 22. 2 negatives make a positive, so I'm going to make that a positive 3. If I add my 22 with my 3, I get 25. And I can subtract 25 over to both sides. So that cancels, and x is equal to 6 minus 25, which gives me negative 19. That's a strange number, but that's okay. Looks like we get negative 19 for x. So here is my solution. It looks like the coordinate that works for this equation is negative 19, 11 for y, and negative 3 for z. And that's it. All right, so let's get to the big picture here of this chapter. So like I said before, there are 3 different types of solutions that we have been solving for systems of equation. And it says here, what does each of them mean graphically? Draw an example of each. So first off, let's label all 3. There's the one solution, the no solution, and the infinite solution, or infinitely many solutions. So in this case, the first one is when you graph 2 lines and they intersect at one point. So this is where two lines intersect at one point, which is typically what happens when you're solving for a system of equation. You figure out where do they intersect, so you find out what x and y values allow that to happen. For no solution, that's when you have two lines that don't intersect, and turns out when they never intersect, then that means you have parallel lines. So we know that parallel lines never intersect, which is also why I want you guys to be mindful when you are looking at an equation that is like y equals mx plus b. Notice what the slope is. If your slope happens to be the same for both equations, then that means you have parallel lines, and you can just stop right there and just say it's no solution, because two lines that are parallel will never intersect. Now for the last one here is infinitely many solutions. For that one is where you have a line, and turns out you have two lines on top of each other. So you might get the same line when you graph them, but you didn't know until you actually graphed them. So you get two of the same lines. Well, it turns out when you have two lines that are the same, they're always going to intersect because they're laying on top of each other. So they intersect everywhere, which is the reason why there are infinitely many solutions for that particular case. So it's kind of hard to always notice what they look like graphically. So we also need to explain it algebraically. So it says here, explain what happens in your algebraic step when you get a system that has no solution and infinitely many solutions. So I'll just go ahead and explain all three. So when you have something that's one solution, that's where you actually find an x value. You come to terms and you actually find an x value. So x is some number and y is also found. So y is some number that you find. And so that's when you can actually like write it as a coordinate. And that is one solution. Then there is the no solution situation where maybe things canceled, but then you end up getting one side to be 0 and the other side to be some number, and 0 doesn't equal that number. So when you have a mismatch, or when both sides don't equal each other, this is no solution. And then the last one here is infinitely many solutions, whereas kind of like one of the examples that we saw earlier in the first page where everything cancel and both sides end up being 0 on both sides. So 0 does equal 0. If this is the case, then that means you have an infinitely many solutions. It's just saying that, well, because they canceled out perfectly, they must have been the same lines. So that means they're infinitely many solutions. All right, and that's it for this review. I hope you found it helpful. Let me know if you guys have any questions. Bye.